this computer. All right, so we're recording. What I think we should do is let me make sure I can share this. We're going to review a test 2, like examen 2. Even though you haven't started your review of unit 3, it's fine because it's a lot of it is very logical. And I'll teach as I go along, and then you can go back and review, right? So let's not waste time in that way. And the chat is here. So I'm going to share I want to share my, if I share screen, let me close all these things. I have to close a number of things. All right. Let's see about projecting. All right, so I cannot read the chat when I share my screen. Oh no, here, wait, I can do this with the iPad. Hold on. iPhone, iPad cable. Yeah, let's do that. You see my iPad? Anyone?
Yes.
Yeah. Do you see the chat? Can you see everything in Zoom? I can see the chat. All right, so you can write in the chat if you prefer. So here are some questions that will be exam 2 type questions. Okay, so I ask you, what are the weaknesses of the discounted payback system of evaluating investments? What is the payback system? So what I say in the notes, what I do in the notes is I talk about the net present value rule as that rule used to determine if an investment is profitable or viable, feasible. Okay, so we look at the present value of future cash flows as a result of an initial investment, and we determine if its NPV is positive. So we know that rule already. But then I go on to introduce other methods of valuing whether an investment is worth it. And I begin with a very, a very simple idea, concept, but you're looking at a different thing. We're looking here at when or how long before the investment expense is returned. How long before you recover the costs of the investment? So in this way, even though NPV gives you a dollar amount and you see if the NPV is greater than 0 to invest, the payback period gives you a result in years, and then you have to decide if that's soon enough. Okay, so maybe if you're the decision maker, you can determine if you think it's good enough, or you might have to bring it to somebody else, right? So you might have your supervisor, or you have to present it to the CFO of the company if it's not your company, and you have to argue or defend that the project is viable because it's going to pay back in so many years, right? So it's a different look at things. So there are 2 different types of project analysis. Well, actually there are 3 that we'll talk about, but mostly I focus in the notes on one of these 2. Independent project analysis means that you have enough money to invest in several projects, and you're just evaluating whether this, one at a time, whether they're profitable. So you just, for the NPV, if you're using that, you're simply going to look to see if the NPV is positive, and all NPV projects, all positive NPV projects will be pursued. The other way is where you have to choose. You do not have enough to afford, you don't have enough capital to afford several projects or 2 projects. You have to pick one. And in that case, you have to, with the NPV rule, you're going to pick the one with the greatest NPV, right? Because that is likely to give you the highest profits. Now, what about the payback period rule? So we would pick the projects, all projects that pay back within a certain number of years. And the number of years, again, if it's your business, it's up to you what you think is enough years, right? If it's somebody else, someone higher up, a supervisor making a decision, they might have a set number of years. In that case, all projects that pay back within that specified number of years will be pursued. If you're choosing, though, and conducting a mutually exclusive project analysis, you only pursue the project that pays back quickest. What do you perceive as a problem with this method? Why is it that we have something like NPV rule rather than why didn't I teach you about payback period rule before? What's a possible problem with this? So that's the nature of the question on the test.
I mean, Professor, could it be because of inflation that value or that money that you would receive in the period or terms would diminish or change?
Very good point. Okay, very good point. So now we're looking at uncertainty, right, due to inflation. So let me tell you this. For this unit and everything before this, I was giving you the cash flows. You see, for instance, here I give you a set of cash flows, and you have to trust me, right, that this is correct. Basically, you're just trusting me that I've given you the right numbers, and you trust me that 10% is the appropriate risk-adjusted rate of return to use to evaluate these cash flows. So as he's mentioning, well, should it be 10%? Should I be including inflation? What should I be doing here? Well, so these are very good questions, but in fact, in terms of my question to you, why is payback period rule, why is it not as good as NPV? I'm putting an R for rule. I'll just put like that. In fact, if there's a problem with inflation, that will affect both NPV and payback period. However, you do raise a point that I'm ignoring time value of money here, right? If I just go and add up the cash flows, so for example, let's say here's my set of cash flows. Now the payback period would be what? All right, so let's see. Initial outlay should be $1,000, and they use a cost of capital. This is the required rate of return. In other words, this is the opportunity cost of investing in this project, because if we didn't pursue this project, then we'd pursue another one that would give us 10%. So that's the opportunity cost of investing. And what you see here is if I was to add up these cash flows, after the first year, it's $200. After the second year, how much is it? Well, it's going to be 200, 400. You're just adding up. So let's see. Let me move over. I'm going to move this over. We're going to talk about this in a moment because it didn't work. And I'll explain what this is going on in this busy slide. I have to. All right, so what I'm going to do here is just calculate what I call the accumulated. And you can do this on Excel, you know, if you have many years to look at. So I'm going to call this accumulated cash flows. That's what that stands for. So the accumulated cash flows at the end of the first year are $200. At the end of the second year, we'll just add them, $600. At the end of the third year, $1,400. At the end of the fourth year, it's going to be $1,700. Did I do that correctly? So I'm just adding this and this, and then adding 600 to 700 and 1,400 to 300. So those are the accumulated cash flows. At what point do we see that we've made $1,000? So in here, somewhere in here is the payback period between the second and the third year. So that's how you would calculate it. You'd say between second and third, and I'm going to show you how to be more precise. All right, we're going to talk about some more calculation we can do to be more precise about exactly where between the second and the third year. And I am going to, I really want to move this down. It's a little slanted. Okay. The problem, as mentioned, is that at first, I'm not even using a discount rate to calculate these, right? All they've done is added these cash flows, but we know there's a time value of money issue. So what I want to tell you first is this ignores concept of time value of money. I haven't done any discounting, anything like that. So, but we can fix that. We can fix that, and we can introduce what's called the discounted payback period. Also gives you a number of years, but discounts the values first. So here we have, that's why I have these other columns in place. Let's get the present value of cash flows first. We'll get the present value of cash flows first. So how did I do that? I compute 200 divided by 1 period of discounting. You see? Put that in your calculator and you'll see that number. And you can do this in Excel as well. See if I have time, I'll show you that. Or you can do it yourself. And this one is 3. This one comes from 400 divided by 1.1 squared. So this one is equal to 182. This one is equal to 331. So this is what I discuss in the videos, but I'm going to try and make this different by solving the exam. Okay. So what I should do then is do what I did here, add up as I go along. So I will take 182 as my first year of discounted cash flows. In the second year, I want to accumulate 182 with the 331 and I get 513. And then I want to take 513 and add 526, and that will be the third year. Okay, so anyone have questions about what I did here? Is it clear? Don't be shy, because I'm going to keep going. There's lots to show you. All right, so now you see the answer doesn't change if I say between second and third year, because here it's between the second and the third year, but also here it's between the second and third year. However, you pay back much sooner. The payback is much sooner. The recovery of cost is much sooner. So we call this the discounted payback period is between the second and third year but it's sooner because it's $1,039. And why I say sooner is because the technique we're going to use to figure this out is treat this third year. In the third year, you see its discounted value is 526. We're going to spread out the 526 evenly over the year and find the point in that year where we've made the extra money to get $1,000. So that's what this calculation is. This is calculating precisely what the discounted payback period is. It's using the second year because somewhere between the second and the third year it pays back. And then we're going to, out of the third year, 526, I'm going to look at the remainder. What remains to get to 1,000? Well, we've made 513 in discounted cash flow. So it's 1,000 is what we want. So that leaves 487. So 487 divided by 526 plus 2. This is this is, sorry, it's not going to pay sooner. What am I thinking? It's going to take longer, right? It's going to take longer to pay back than here because we're spreading out. We're going to spread out 700 over the third year, and that's going to pay back sooner. I said it backwards. So this is going to take almost 3 years. It's slower because there's less between 526 discounted versus 700 in the third year. All right, so that's how we fix the issue of ignoring time value of money. The issue of inflation would, if unexpected inflation would affect both NPV and DPBP because I'm doing the discounting and ignoring possible unexpected inflation. So that's not the big problem. The big problem is the issue of ignoring the time value of money. But there continues to be a problem that exists in a payback period rule and using the discounted payback period rule. What remain as problems for using this rule or disadvantages that you perceive? So let me make a note about the inflation. Okay, so one is that there are two. One is that I completely ignored this fourth cash flow, or this fourth, this fourth cash flow here, 300. I've completely ignored it. Now 300 is not so impressive, but I've just completely ignored it to calculate this. It hasn't gone into the calculation. It's not part of the accumulated cash flows. I just ignore it. What if that was $3 million? What if 4 was $3 million? Would it be silly to call? Would it be inappropriate or a huge oversight to ignore $3 million that are coming? Probably, right? So it's just going to ignore it. It's not even going to put it in the calculation. Now, you might be really pressed that you need this project to pay back soon. So the The issue of the threshold, the cutoff, is part of a problem too. How strict are you going to be, and why? Why are you going to say, well, this needs to pay back in 2 years, or this needs to pay back in 3 years, or we're not going to accept the project? When you see something like this payout in 4 years, that would change my mind, right? You might be able to hold out. You might make arrangements that, though you've borrowed this amount, or you've put aside this amount from the other operations of your company, that you're willing to wait that 4th year. So there are 2 things that come out of this discussion, 2 points. We call it the cutoff. We say arbitrary. It's like not set in stone. It's somebody's decision off the cuff, or it's subjective, right? It's subjective, arbitrary, and some person in an executive position could have one cutoff and another one a different one. So, for example, in our exercise, if the cutoff was 2 years, we would reject that project. We wouldn't pursue it. But if the cutoff was 3 years, we would accept the project. We would pursue the project. Now, I haven't told you what the project is, but we'll talk more about kinds of projects and things. And in Unit 4, we actually determine the projection of cash flows, right? We until Unit 4, I'm just giving you this projection of cash flows. Okay, so the second problem is it ignores future cash flows, which could have a huge impact on the company, right? In our case, in this example, it doesn't, but so like I think in the example, I suggest that in the example, I suggest that $3 million coming in 4 years. Well, that'll have a huge impact. Well, why don't I just change my threshold cutoff period, or just forget about even doing the payback period, because I know that's more than I even could imagine, right? So not doing the project. So I'll hold out for 4 years. So what if it was detrimental? What if it was a cash flow? What if it was negative 4 million? What if we lost? This changes the perspective completely. And if we were to calculate NPV would tell us reject the project. So calculating a payback period is just irrelevant. So with all of this said, the payback period and the discounted payback period rule should not be used in isolation. You probably want to use it with the NPV as well. So you would report to your supervisors, or you would in your own company make a decision looking at both. The project will recover costs, the investment will recover costs in so many years, and then looking also at the NPV to see that the project is profitable. Make sense? All right, so let's go back to the question. And let's see if you can answer it. Oh, you can put it in the chat or you can tell me. Come on, are you guys listening? What's the answer? No one? Is this thing working? Are you there? Are we connected?
Yeah, we're here.
Okay, take a chance. What do you think the answer is? Question 1. Okay, I'll put the notes back. Maybe you want to see the notes. What did I write here? I should say on the company. No idea. It's right here in red.
Yeah, but now I don't remember the question.
Okay, now go back to the question.
Yes,
Okay,
please.
I'll take it with me. How about I take these notes with me? I'll take them to the question. Oops, that didn't work. Do it again. I want to take this one. All right, so do that there.
Well, it's C.
Uh-huh. So this is true. Is D true?
Yeah, it cut off the arbitrary also.
Right. Okay, so E is the answer. Very good. Good for you. Okay, so let's do the next one, unless you have questions. Very good. So you learned something today. And you can still go back and watch the videos I made. It won't hurt. But yeah, so let's finish. Let's do the next one. So the next one is about another technique that I show you. And it's called the IRR, or internal rate of return. Have you ever heard of that before? No?
Yeah, I think in 3106.
Oh, yeah? Okay, so internal rate of return. So we're gonna go a little more deep with internal rate of return. So this is an example. This is an investment project. And I will distinguish it from what's called a financed project. So this is an investment project. It means that we invest this amount to receive these cash flows later. And the whole idea of where these numbers come from, like I said, we'll talk about in unit 4. For now, take them as given. So we anticipate by the end of year 1, and again, that's also an assumption, right? Because cash flows occur throughout each period, but we use to use our formulas, we're going to say that we're going to assume their end of year payments. So this is $800 and then $900. And if you want to feel, if you want this to be more realistic for a big company, you can add 3 more zeros and think of these as millions, but it's a lot more zeros and much more complicated. But we could say these are in thousands of dollars, and I'm going to give you an example in unit 4 like that. But okay, so we're going to use simple numbers, but it's relevant for big projects as well, same techniques. And what we're going to do is calculate the internal rate of return, which is computed where the NPV is 0. In other words, what is the discount rate that makes the project break even? NPV of 0. Remember, we only invest in projects with an NPV greater than 0, but from this point on, you should consider this value because it'll tell you where the break-even project is. All right, so you're going to have to write this, like this is the NPV equals 0. So in a test situation, you want to write this equation out. Now this is a polynomial. If I was to solve this for I or R, I would not be able to do it like on a piece of paper. Okay, it won't work. This is probably the main reason you have your finance calculator, so that you can make this calculation. All right. In the finance calculator or in Excel, it uses a computer to iterate, like it picks different numbers and plugs them in to try and make this equation equal 0. That's what it's going to do. So, and I'm going to show you how to do it as well, because when the calculator can't make the calculation, you need some backup, right? So we're going to learn how to make this calculation ourselves. Another way to look at that is putting this initial investment on the other side and say, what's the IRR for, what would equate this, what would make these equal? So notice that as the IRR increases, as the number goes up, what happens? Or let's look at it here. As the number that goes in here goes up, it makes the denominator bigger and makes the overall number smaller. So there's a pattern here, because as the discount rate that I put in here increases, I'm less able to offset, the negative 2200 to make this 0. So in fact, let's look at it a different way. Let's do it like this. As the discount rate falls, the overall number goes up, and it's better at offsetting the 2000, right? 2200. So we can depict this relationship here. what I've plotted here are the discount rate and the net present value. And you see, as I put, so this line is the equation. And for different discount rates, I get different values. For instance, if I put 0 in that formula, what do you get? Let's go back to the formula. Let's put 0 into the formula. If you put 0, 0, 0, 0, then it's 800, 900, 500, 1600 minus 2200. So that calculation, if these were, so I'm not dividing by 0. All I'm going to do is divide by 1, right? So if IRR is equal to 0, then the equation is 1600. What equation is it? Or I'll say Gibbs. In other words, NPV is equal to 1600. And that's what you have here. So that's where NPV is 1600, is where the discount rate is 0. Now, if you start adding more and more higher discount rates in there, the formula goes down because you're less able to offset the 2200 to this point. This point where we actually get the 0, right, where this actually equals 0, is where the IRR is. So looking at this graph, what should the discount rate be for us to accept the project? So let's stare at this a bit. And the question is, what should the discount rate be for me to accept the project? So there's a bunch of things on this page. What is the one that speaks to you? Probably this one here. So NPV greater than 0 means accept the project. Everyone agree? So for any of these discount rates in this range, we can accept the project. If a company, or if you have a predetermined discount rate, one that you say, this is my trade-off, this is my opportunity cost of investing in this project, you already have one, it needs to fall in here for this project to be viable. If you don't have one, this shows you that the one that you should be using should be between here and here to make the project viable. It should be between 0 and 23.3%. Now, you shouldn't pick discount rates based on this. It just gives you a range of values to consider where you would say, well, you know, if I don't invest in this, I can put the money in a hedge fund that promises to pay me 12%. And like this looks, you know, this is not, doesn't look as risky as maybe I feel more confident doing this than investing in the hedge fund. So even though it's only 12% return over there, I might go with something in here. I'll go with a 12% as my kind of opportunity cost, and it does satisfy, it does fall in here, and the project will be profitable, right? So that is how we do this. That's what IRR is. I showed you how to calculate it, and I showed you what it is in relation to the NPV. It is where the NPV of the project is 0 is where you find your IRR. I left this big blank in the notes. If you print the notes, you can show the steps of calculating it there. And we're going to do that together now. So here's the project. Sorry, let me get the cash flows. This is the project cash flows. So if you were to make that graph, that's called the NPV profile. This is how you would make it. You would put the cash flows into your CF keys of your calculator and then calculate the NPV for different discount rates. And that will generate the NPV profile. And you see that you cross over and the IRR must be in here. And this is where I mentioned that the calculator will iterate. It will iterate in between 20 and 25 to try and get where the NPV is 0. And I'll show you how to do that manually as well. Okay, so let's do this. Let's put these in our calculator and get the IRR, but then I'll also show you how to generate this. Even though you have the answer, you need to know how to make an NPV profile and find the IRR manually. Okay, let's put this in the calculator. So let's go to the CF keys. Make sure there's nothing in there. Aha, I have something in there. So I have to second clear work. And I start entering the values, which were 2200 negative, enter, down. Now I put 800, enter, down, down, because there's only one 800. Then 900, enter, down, down. Then 500, enter, down, down. And 1600, enter, down, down. So I have everything in there. Let's press IRR. Now it says 0 because you have to ask it to compute. So compute, and there you have 23.3. Does anyone want me to do it again? Or you want me to give you a chance to try it? Pull out your calculator, your phone.
After I press IRR, do I press enter and down?
No, you're going to press IRR and compute, CPT.
Okay, thank you.
Sure.
What was the number that came after 900?
Oh, sorry. I took a picture of it myself. 500
Okay,
and then 1600. Here, take a
Okay.
picture of it so you can follow. Take a picture of the, unless you're doing both on the phone, and then you have to jump between the screens. Yeah, 500 and 1600.
got it. Thank you.
Sure. And you got the number?
Yes.
Okay, great. All right, so that we've done that. We've calculated the IRR. We very simply now we found it here, 23.3. What we want to do next is generate the whole line. All right, so the way we're going to do that, keep your cash flows in the calculator. We're just going to continually change the discount rate and calculate the NPV instead. And I'll show you how to do that. So I'll do a few and then we'll go back. So what I'm going to do now is hit the CF keys, hit NPV and change. Well, right now it's 0. So I'm going to use 0 first. 0, enter, and compute NPV. You see, it's 1600, 1600. So let's go back and look at that. So that gave me this one here. Now I want the rest. It should be smaller. So we're going to go by increments of 5 and generate all of this up until 25%. So take a photo of that so you can follow along. I probably can split. I don't know. I tried to do this before. Let's see if I can split the view. I don't know. Oh yeah, split view, just like I said. Okay, so, well, that doesn't really help. I want to see both at the same time. Slide over, split view. No, it just disappears. They changed the application. Oh, it does work. Okay, I got them both on. Split view. So what I want to do next is I want to change the discount rate to 5%. So then do that again. NPV, now change this to 5, enter. Down and compute again. You see? That's the second one. Let's put in 10%. So again, NPV 10, enter, down, compute 739.
Okay, but we use the same numbers from above, right?
You leave all the CFs in there, right? The cash flows are in there, and you just keep changing the discount rate. So to review, what we did was first put these in and calculate the IRR. And then we're now calculating the NPV as though we don't know the IRR, but we're trying to find it. So we keep changing because IRR is where NPV is 0. They're very closely, related. So we just keep changing the discount rate. Let me change it again. So hit NPV, change to 15. And just keep going. Oh, sorry. So NPV now change it to 20. Just don't forget to hit it in NPV each time, so you recompute it. And the last one now will be negative. I want to change it to 25 and compute, and there it is, negative. So now that it's negative, I know that the internal rate of return is in there. So I should magnify that space, that range. And I want to go between 20. Oh, let me make it. I want to go between 20 and 25. Halfway. So what about 22.5%? What do you get? So I want to put in 22.5, enter.
35.32.
Right, so it's still positive. So it's positive in here still because it's going to cross. Now the main thing about this polynomial is it's monotonic. It means it's still going to go down. So I know the direction. I know that it's going to keep going down. It's still positive, but it's still going to go down. So that means that it must be, the IRR must be in here. So then you expand that. So IRR is in here. So this is what the calculator is doing to get closer and closer. Between here and here, what's halfway between there and there? You divide the space in half and you keep choosing where, it's going to be negative because it crosses in there. I'll do one more. So what's halfway between 22.5 and 25? It's like 20. $23.75. Okay, so let's split it with, I'm going to make this smaller.
But it's never gonna be exactly 0, right?
It will, but we're not going to waste too much time trying to be perfect. We are going to, yeah, this is going to be a mess. I can't do it in this screen. It will be exactly 0 if you keep going with many, many decimal places, but I won't expect that from you. Mostly, I want you to understand how to do this in general and just give me, a smaller range of values, something approximate. But for most problems, you'll be able to use your calculator to get it. But the point is, this is the method that calculator uses, and you should be able to replicate it. So So let's see, I'm not gonna keep going because I can't do it in the screen. Let's split this, let's put the screen back. Okay. Okay. You guys are understanding, right? So then what I would do is. You guys hear the wind? I need to fix the door. So I said 23.75, right? So then you're going to say between 23.75 and 25. I have to do this in blue. I have a color system, 23.75 and 25. And so if you put that in,
Negative 19.76.
but it's positive, right? So it's positive still?
No, it's negative.
Oh, it's negative. Tell me the number.
Negative 19.76.
Okay, so that means that we went between 22.5 and that's in dollars. So that means that it crosses in here. Because it switched to negative, so it means IRR in here. So we're getting closer and closer. So I mean, if you could say it's between 22.5 and 23.75, and in fact, it turns out to be 23. So 23.3. So you could just try 23 at that point to get an idea, and that would be very close to zero. So let's put 23 in. Let's put in 23 to see what it looks like. And so, yeah, it's not exactly zero. But if you start putting decimals, you're getting into zero, you see? And that's pretty much zero. So the fact that the answer is 23.3 is also rounded, but to more decimal places, like the one when we first solved it. Let's go back to when we first solved it and we computed IRR. You see, it's not exactly 23.3, it's 23.2956566. So that will make it zero. Let's store that number. Let's put that number into the discount rate. And now compute. And you see that number has 11 zeros, or it has 10 zeros in front of the one. So it's 0.00000001. Zero. Got it? That's what 1.5, whoops. 1.03 negative times 10 to the negative 11. So that it has 10 zeros in front of the one. All right. Questions? So you can get the
Is
IR.
it bad that it's negative?
That's a negative, yeah, but it's a very zero negative, very small.
So it's acceptable. Because
Okay,
it's very
zero,
small.
It's 0.000000. Yes, Yeah, even though it's negative, it's zero. Very good question. So if I put in, so let's say, let me take a picture of the number. So what did we put in again? We put that in. Okay, so in fact, um, these are all zeros here. 1, 2, 3, 4, 5. You get the point. That's zero. Got it?
Yes.
After it depends on the test, like anything smaller than that will equal zero. Like I'll say maybe 5 decimal places, that will be zero. Rounded. So okay, let's continue. Wait, let's go back to the test. Oh, let's go back to this down here. So the chart. So what does it say again? So we learned how to calculate IRR. We learned how the calculator calculates IRR, iterating to find where the equation of NPV is closest to zero. And then the way that we conclude is we only operate where NPV is positive. In other words, the internal rate of return must, in this basic investment type problem, the internal rate of return behaves like a return on investment, and you compare it to the required rate of return. So whatever's required, in our case, it was 10%. So RRR stands for required rate of return. It's the opportunity cost, the cost of capital. These are the terms we use for it for a project. It acts like the interest rate in the formula. So the required rate of return was set at 10%, but we found the IRR is equal to 23.3%. So we interpret that like for every dollar invested, we have a 23.3% return. So that exceeds the required. So we accept the project, right? Because it's 10%. So in this case, we accept the project. All right, so let's go back to the problem and see what we can do. Do we have enough information to solve it? All right, try this. Try that. I'll give you some time. Is there something different about this problem than the one that we did that you've noticed?
That the expenses are the same. That the eight.
Okay, yeah, so this is like easier. Yeah, all the expenses are the same. Well, what about the issue here? Okay, so this company is determining whether they're going to go for this contract. They're going to be given $300,000, and then their expenses of dispersing or conducting or what's the word I'm looking for? In the disbursement of the funds will be $85,000 every period. Those will be their expenses to operate, right? So it's $300,000 that they're getting. Isn't this the opposite? Because they're receiving money up front. So they're receiving money up front. It's not that they're investing. It's opposite. So let's go back to the notes to see how we deal with that. So what we talked about so far is called an investment type project, where the initial outlay is a negative, and then the future cash flows are all positive. If that's the case, we call that an investment project. What if instead it's backwards? You have money up front, like the example where they're being paid up front, so the project's being financed, and then these are their expenses to operate. Is it worth it? So what happens when they're reversed, when the cash flow signs are reversed? Here's our formula. It would still be the same idea, NPV of 0. This is called a finance project. And just as the cash flows are flipped, so is the pattern of the NPV profile. So you'll see, remembering the last set of cash flows were all positive and then a negative, these ones will be negative and then a positive. And you guys can practice, calculating those again. It's like we did before. But now the interpretation is different. Let's look at the graph to talk about the interpretation. So it looks like this now, okay? So as the cash flows flip, the equation flips, so does the graph. This is where you'll find the internal rate of return. Now, how do we interpret the result? Let me go back and get the number. It's 14.37. So it's kind of on the screen, but how would you interpret the finding? What does this mean now? When should we accept the project? Go back to remembering this is all based on the NPV, right? The way we calculate IRR. And I'm just going to check my settings for a second. You guys hear all the noise over here? I'm going to suppress the sound.
By the way, we don't hear anything. Don't worry.
Yeah, the noise suppression is on automatically, so that's good. All right. I got a dog crying upstairs, and I have not my dog, and I have the wind blowing, and I have air conditioner going. So if you don't hear it, that's great. Okay, so this is all based on the NPV, and we the NPV rule will always give us the right answer, right? So where is NPV positive on the NPV profile? So this is where NPV is positive, see? So you should accept the project where the NPV is positive. What does that translate into? As long as the discount rate is greater than the internal rate of return, you should accept the project. It's opposite. So we have to change the interpretation of what IRR was. Before, just before this, we were saying it was a return on investment. It showed us the return that we could compare to the discount rate that was the required return. And we saw that in the last example, it exceeded what was required, so we accepted the project. In this case, it's reversed. So instead of seeing this as a return on investment, this is actually the cost of borrowing. It's like you're borrowing that money to operate, provide services or provide product, right, to produce something. So this acts like a borrowing rate, and our return, the discount rate, the required rate of return should exceed that borrowing rate. So we interpret things backwards, okay? Just like the graph is backwards, the cash flows are backwards, and signs being first, you get a positive cash flow or inflow, and then you have negative because those are cash outflows from offering the product or service or whatever it is. So in this case, we're going to get, let me get back to, okay, so trust me, you can practice calculating the NPV profile there. And here is, and I did provide a summary page with all this information, but that something like this will be on the summary page. If you have an investment project, you accept the project if the internal rate of return exceeds the required rate. In a finance project, the internal rate of return, the rate of borrowing, should not exceed the required rate of return. Or in other words, the required rate of return should exceed the IRR, however you want to write that or think about that. And how to identify an investment project? It should have a first a cash flow that's negative to begin with, and then only one sign change. Okay, the future cash flows should all be positive. For a finance project, the first cash flow is positive, and the future cash flows are all negatives. And what we're going to talk about after we solve this problem on the test is, what if there's a mix of positive and negatives? What do you do there? So let's solve the test problem first. And see how you do the year. So try this.
So it's basically the same process but without negative.
It's the same process, but this is positive and those are all negatives. So this one will be a positive in your calculator, and this will be negative 85,000 for 5 periods. So I'll show you with my calculator, but try it first and see if you can pick a letter, and then I'll show you how to do it if you didn't get it.
And in this kind of problem, we want the IRR to be greater than the RRR, right?
Right, so this is opposite. You want, you want the opposite. You want your required rate of return, which is, what is it? Oh, yeah, sorry. They don't give it to you. So you have to figure out the range. Basically you want NPV to be positive. So yeah, that's the whole question. Which way are you gonna want this, right?
Okay, so I think it's C, greater than
Very
12 point.
Very good. That's the answer. So let's do this problem for others. Very good. That's right. Okay, so what you're gonna do is see that the cash flows look like so that's what it looks like. Now let's put this in our calculator, and it's easy to put in. So everybody take note of that. Let me do the split screen. You can see that still. And so I got to clear my work and begin with 300,000, enter down, and now 85,000 negative. Don't forget the negative. Enter down and then tell it 5, right? You want 5 of those. Enter down and you're done. That's it. Now ask for IRR and to compute, and you get this number. So you get the number, but you're not finished because you have to figure out how to interpret that. So I explained before that this is like a borrowing rate, and we want to borrow at a low rate, lower than our discount rate. So this has to be the discount rate, in other words, or the required rate of return. We'll just call it the required rate of return. Must be greater than 12.086%. Okay, because it's financed. So the answer, that's why the answer is, I wanted to go with this one, is C. Questions? All right, so we've done 2 problems on the test, and you just learned as we're going here. Questions? Okay, let's move to the next one. So you know something about NPV, you know something about IRR, and this problem has a negative first cash flow and all positive. So it's the regular way. This is an investment project. So see if you can answer this question.
Well, A and B are true, but I don't know exactly how to get D. So I assume the E is the answer.
Right. Okay, right, okay, so to get the NPV, you know how to put them in and ask for the NPV. You know how to calculate IRR, so these were true. So these ones you can get. Now C, when will a project have more than one IRR? It's when there's more than one sign change. So these cash flows went from negative to positive. And that's it. So there's no more than one. There's only one IRR. If there's a sign change, there could be as many as two. That's how it works. We're going to talk about that next. So it doesn't have to be two, but there could be as many as two. If they're in general, if there are K sign changes, there are as many. There could be. K IRRs. Okay, it's just a general approach for the polynomial solving it. All right, so in this case, though, there can't be more because it's just one sign change. PI you'll see in the notes. You'll see that in the notes. And then A, B, and D. So we have to check this. Now the PI. So just to recap, NPV gives you a dollar amount. The payback period and the discounted payback period will give you the number of years as a metric. And the IRR gives you a percentage as a metric. PI gives you a ratio. So they're all different measures with the same data, right? They're different measures and they are interpreted in different ways. And some of them are better than the others given the conditions. So you'll get the idea when you finish watching the videos. So PI is actually a ratio of the present value of the future cash flows divided by the initial investment. So see if you can calculate that quickly. You can get this present value of future cash flows by putting these in the calculator without putting in the, well, you put 0 in the place of the initial cash flow because you just want the future cash flow. So you're basically doing the benefits over the cost, right? This is a cost benefit analysis, all in time value, in discounted dollars. So check if you get 1.06 for that. And then, like I say, you'll go more rigorously through with the notes. Just do a split view. So what I'm saying is, it's clear work, and let's put 0 in first, and then 85. No, this is 7,000. Sorry, this is 7,000. I'm thinking of the other problem, and you're going to enter that for 4, frequency of 4, and that's it. And then ask for NPV. Whoops. Ask for NPV with a discount rate of 12. So that's the present value of future cash flows because I put a 0 first. And then divide by the cost of 20,000. And you get 1.06. Let me know if you want me to do that again.
You redo it, please.
Redo it? Okay. Okay, from the top. Okay, so you put a 0 as the initial cash flow because I just want the present value of the future. I don't care about the initial cash flow because I'm going to make a ratio instead of adding and subtracting benefits and costs. So then I'm going to say that's my 0, and then I put 7,000. And then I say there's 4 7,000s. Enter, and then that's it. And then I ask for the NPV. I have to put 12% in there and compute NPV. So get that and let me know when you're done.
Yeah, already done, but then
And
what?
then divide by 20,000. Okay. And you get the 1.06.
Okay, got it, thank you.
Great. All right. Okay. So then we know that this is true. And so E is the answer. Okay, so you guys have learned a little bit of everything. Let's go to the next page. Okay. So in this test, I don't have anything on multiple IRRs, so we'll have to go back to that. Actually, let's do this one. Actually, yeah, let's go to the notes and then we'll come back to this one. I'm gonna go back to the notes because you need this. Okay, let's move. No, it's not letting me take it. Just erase it. Okay, so as I mentioned, if you have two sign changes, and that happens here, negative, positive, and then a negative again, two sign changes mean up to 2 IRRs. And you can see why, because it'll make a polynomial, it'll make a parabola kind of shape. So in terms of the NPV profile, let's do this again. Okay, so this is the NPV. This is the discount rate. And there you go. You see, if it's a polynomial going up, it'll cross twice. So that's why we say up to. It could be 2. It could also be like this. and it hits twice. There and there. Kind of off, but let's see. Right? But it also could be something, and you'll see some of the examples where, you know, we're not going to use a discount rate that's negative. That doesn't make sense, right? A discount rate that negative means we're paying to operate, and that's not, I think we want to make a return. We don't want to be at a loss. So, but mathematically, you could get something like that. Like it's a really flat one. Let me do that again. Let me move this. Let me do this again. I can I'll put it up here. So what if it goes like, no, I want it to curve. I want it to curve. Okay, so let's do it like this there. So that mathematically that could be the NPV. And then that's the IRR there. Now it crossed over here, but we won't use that one, right? Because we won't have a negative discount rate. Okay, what else can happen? This could happen where it doesn't even cross. What do you do if it doesn't even cross? Well, this project is always a positive NPV project, so you should always accept that project. What if it's never crosses, but it's going down? Well, it never crosses, there's no IRRs, but it's not because there are no IRRs that you don't operate, because in this case, you will, right? You're going to pursue the project. But when it's all down here, the NPV will always be negative, so you won't operate for that reason. So what we have to talk about then, I'm showing you the graphs because you should be able to generate the graphs, and you can do this in somewhere like Excel or by hand. It shouldn't be a problem, right? Because I showed you how to generate the NPV profile. The important thing, the hard part, not the challenge, is the interpretation, which is not even that challenging, but you got to get the graph right, and then you got to do the interpretation. So somewhere like this, what do you do? When do you invest in the project? Let's look at this graph here. So looking here, if this was my NPV profile, when should we invest in the project? What does this tell us? Presumably this is a graph of a function with no limits, so it just keeps going both directions. But the dots are here, so that's most relevant. So those mark the IRRs. So what do I say? Remember, when we don't know what to do, we go to the NPV rule. So that's IRR1 and that's IRR2. I have to show you how to get those from the calculator. Or in our case, we'll only be able to get one, but I'll show you how to get the second one. So how do you summarize if that's your picture? Again, where's the NPV positive? The NPV is only positive up here, right? So you should only invest in those two cases. You should only invest where it's positive. So as long as the required rate of return is less than the internal rate of return number one, or the required rate of return is greater than the internal rate of return two, should you invest in this project. Remember, on this axis is the discount rate, or the RRR. All right, I did that one. You're gonna try the next one. When should you invest in this project here?
So that project is almost never positive, so
Right, but still, answer the question. It's very small range, but when is it positive?
yeah, it's positive on the quadrant number one because it's very small range.
In the small range. So we just say, except only if the internal, required rate of return is between right? So that's how we analyze. It's not enough just to get a number. You have to see the big picture and where's the NPV positive. But those numbers are important to give you those conditions or the range of values. All right. So it depends on the scale. I didn't put a scale. If that was in, those were in large numbers. If that was like, if this is 20% and that's 30%, that's a good range for the required rate of return. Okay, so let's solve some problems, all right? So I gave, if you understood that, you're going to be fine. If you still didn't understand, it's fine as well, because we're going to go through it now. We're going to go through this now. So let's see, let's look at these cash flows. Put these cash flows into your calculator and tell me what is the internal rate of return for those cash flows. Did you get something? It's possible you're getting nothing, like an error. It is possible. This is the NPV profile for these cash flows. If I enter these into my calculator, I'm going to go to the CF keys in the clear. And then enter 260. Down. And then a positive 250. One of those, and then 300. One of those, and then 20. One of those, and then negative 340. And now I hit IRR and ask to compute, and I get the number 1152. Do you get that?
You repeat it because I keep getting an error.
Okay, it's possible. Which calculator are you using? Are you using
Oh,
this?
Yeah, I'm using the same, but I'm think I'm doing something wrong.
No. Okay, if you're not doing something wrong, it's possible that you're just getting an error because the calculator can't do it. That's why we have to learn the NPV profile approach. But let me do it again. And make sure what it is. So CF, so I cleared everything, and then you enter 260 negative, enter, scroll down. 250 positive, enter, scroll down. There's only one, so you scroll again, go to C2. Then 300, enter down, there's only one, keep going, C3. 20, enter down, down. Are you with me so far? And the last one is a negative. It's absolutely possible that your calculator won't do it. It's a very complex solution.
Okay, okay. CO1 is 260, and now FO1 is 1.
Negative 260.
Is the second one.
No, the first one is negative 260.
Okay, and the second one is positive.
Okay, so initially let me go back. Let me do the split screen. Let's do the split screen. You can see the numbers. There. So the first one is negative. Then you get a positive. And a 1, and then a positive 300. And then 1, and then positive 20. And 1, and negative 340. To get the positive and negative, it's on the reset button beside the punto.
Yeah. I think the thing I was doing wrong, I wasn't putting the last negative, the negative 300.
Okay, good. Okay. So now you got it?
Let me just write again here. I'm on CO3. Negative 340. Press enter. And now I press compute. IRR. Yeah, I got it.
Great. Okay, so we got one. We got one together here.
Yeah, because if I didn't put the negative, it was going error.
Okay, good. So now you know. Yeah, you got to get the negatives right. And it's possible because you're used to putting positives only, and now you have to actually possibly have a negative. So you have to keep your eyes wide open, right, for this. All right, so we found one. Now I'm saying one because here's the NPV profile and showing. Now look how long this is. I made it very long. If you don't want to start that long, you can just do something. And look, I even went into the negatives because even though a discount rate won't be negative, we have to find all the possible IRR. So I go into the negatives. In this class, I will usually tell you what range to use. Okay, so you'll see in the exercise, the practice exercises, I tell you how to go looking for the IRR. In this case, I started at -10 and went to 35. So what you can do just to begin with is, take on a sheet of paper, or you can do this in Excel very efficiently. Maybe I'll do that now. We have time, right? I'll put it in Excel. Let me put this in Excel and I'll show you. Hopefully we don't have problems with Excel because I always get surprises, it seems. So let's go to Excel. And this is on my iPad. So forgive me if I stutter over here. So I'm going to put this percent. Oh, we have a Teclado side. I'm not going to like that. Mhm. And then MPV here. So if you are going to use Excel, you have to send me the Excel sheet, not as a PDF, as an Excel document, so I can see all your formulas. All right, so I said start at -10. And then what do we put here? So to get the NPV in Excel, actually, let's put the cash flows over here. It looks a little different on the computer, right? But this is the iPad. So 0 is actually on the chart. So 0, 1, sometimes I don't put 0 on the chart of cash flow. So be careful about that too. Now I think I remember NPV in Excel is just the present value of future cash flows. I don't think it gives you, I think NPV is just the present value. It doesn't use the initial cash flow, but what do let's see. Oh, it doesn't even tell me what I'm supposed to put there. Hold on. I need to go into my other Excel. Okay, you begin with the rate. In this example, well, we want to use all the different rates, right? So I'm going to put that, and then comma, and then you put the values. And let's see what we get. Sorry, this is impromptu. Did I get it right? No. Okay, so then you have to, I think you can only do that, and then you have to add this. No, that didn't work. What am I doing wrong? I have to remember how NPV works. Why is it 31? It's negative 24. Why is that not working? Negative 10%. Do I have to make it a decimal? Okay, so this is going to be confusing. I'll explain in a second. So you got to be careful with Excel. All right, that worked. Okay, so Excel, just make a note that in Excel, NPV computes present value of future cash flows. And then you have to add the initial cash flow. And it's weird because it says NPV, but it doesn't even use the initial cash flow, which is usually the cost or the investment. So whatever, that's Excel. So in Excel, NPV computes only present value future cash flow. So that's why I'll take the formula to show you. I'll put it here. Oh, that didn't work. That's not good. What I just did. Forget that. The formula here. Give me a second. All right, so when you put an apostrophe, it makes it it doesn't make it a formula anymore. All right, so this is what I got. This means negative. Let's round it so it looks like the notes. I'm going to round it using the where did I do that again? No. Sorry. Okay, anyway, that's 103 negative. That's what it means. It's in red. If brackets around it, and it rounds off to 103 negative. We'll just leave that. So I had to tell them the rate, which has to be as a decimal. And then I used only the future cash flows, and then I added in the first initial cash flow. It's good to practice different methods, but I mean, you need to learn one first. I'm just showing you here to generate the profile, which you might want to do in Excel, because if it's really long, right, it's easier to do here. So I'm going to go up to negative 0.05, and then to 0, and then to 10%, and then to 15, and 20, 25, 30, 35, 40, 45. Oh no, I didn't go that way. Okay. And then it's very easy to just copy this formula all the way down, right? So this is something's wrong here. Oh, I know why. Because I need to fix B2. All right, so I'll just make this formula. So you have to fix B2. Do you guys use Excel? I have to fix B2 because it's going to stay fixed. Everything else is going to move. No, not everything is going to move. They're all going to stay fixed. So what am I going to do? Do I do that all the way through? This is not the best, is it? So using these dollar signs, it fixes it no matter if I move this around. So let's see if I get the value. Yes. Okay, let me, whoops. Still did something wrong. All right. This is right. This is right. What happened here? Yeah, see, it's actually, until you figure out how to use Excel, it's going to take time. But you can generate this. You guys should practice just with your calculators. I was able to do all of this, and then what happened? At 5. Oh, I missed 5. That's why. 5, 10, 15, 20, 25, 30, 35. So this should be 12 negative. Why not? Okay, I don't want to waste your time with this. But I guess if you want to use Excel, you got to practice, and I'm trying to make it the easiest way. The easier way is just to put the numbers in, so I don't get the wrong answer. So I'm going to just put the numbers in. I don't know why it's not working. So then just 250. The whole point of it though is to use the cells. 800. I don't know what the next one is. 20 and negative 340. And oh, I know. It was working. I just stopped using the decimals. That's what happened. So yeah, you need to use decimals in Excel. Not on your calculator. You see how much better the calculator is? Or else, I get used to doing it one way. And then I have to remind myself it's the other way. All right, now it worked. So everything's working. So I'm going to go back to using the formula because that's the whole point of using Excel. And here we go. I hate when that happens. Okay, so I've done this in Excel. The numbers look correct. In Excel, NPV computes that. Excel uses decimal for percentages. And just to clarify, I put dollar signs everywhere. So if you want to replicate this, that's how you do it. And you leave this without dollar signs because I wanted to change, go C2, C3, C4. I wanted to go all the way down. I'm going to move this comment here. Okay. Questions? So this shows that it's all negatives there, and then it goes to positive. When it goes to a positive, you know that the IRR is in here. In fact, we found, well, I found, or you found on your calculator, the IRR was 11. It was 11%. Let's go back. I have to see what it was. 11.52%. It's almost 12. And then there's another one between here and here, between 25 and 30%. And we cannot find it ourselves with the calculator. If you have a HP, I think will calculate both of them. And the way you do that is you put into storage a value that overshoots this one here. And I've tried it in this, the BA212, and it doesn't work. Like if I put like 30% store 1, it still doesn't help me get the right IRR. It doesn't work. But in the HP 10V2, it works. And I think in the HP 12, it works. Anyway. So back to Excel. So how do we find the value between here and here? Let's use Excel to do it. Let's just add a bunch of rows, right? Insert some rows and then just do 0.26, 0.27, 0.28. Once you figure out how to use it, it's quite good. 9, and then copy the formula all the way down. So it's between, it looks like it's between 29 and 30%. If you want to even do some more with decimal value estimates, insert rows. So let's try 0.2925 or something like that. 0.295, 0.2975. So I'm going by 0.0025. And then that's it. Hope you're following me on this. Okay, and now, so there you go. So it's very close to 30%. So that's pretty close, right? I'll be happy with that if you were to do this manually and say between, you know, it's almost 30%. It's 29.8 maybe. So what was it? In fact, in the notes, 29.84. You see? So you can do this very carefully in Excel. Does anybody want me to repeat any of this? Are you going to look at the video? Because I'll post the video. But that is how I do it in Excel. So let's try and get, just do one more row, insert one more row, and let's do that. 29, 0.2298. And let's see. Okay, so let's say it turns out IRR is 29.8 something percent. In the notes, I think it was 84. Questions about that? Try and replicate that. Keep it close and keep it, keep it annotated, like put in notes so that you remember the standards for, or the requirements for Excel. The decimals, the rate should be as a percent, and the NPV is not really an NPV, but you have to add in the initial cash flow for it to work. And that's why I did it like this. also using the dollar signs to fix the cell. Questions for me? Oh, let me stop sharing for a second. Okay. Any questions for me?
Yes, Professor. The exam will be on the 31st, and it's going to be virtual. As you said in the first minutes of the Zoom.
Yeah.
Okay.
And it's on unit 3 and 4. All right. So that's how we find the 2. Up to 2. So we found 2, and now the interpretation. Let's look at the interpretation. Here is the drawing. It's going to come up from the negatives and go back down to the negatives. So it looks like this if you were to draw it. And since the NPV is positive, now you don't have to draw it to make a decision, right? Because here I can see where the NPV is positive. The NPV is positive here. So it means that as long as the discount rate is between 11.5 and almost 30, you should accept the project. It's a small range, but it's a lot. Well, it's a small range on the picture, but it's a long range in terms of rates, right? Between 11.5 and 30%. So accept the project provided the required rate of return is between 11.5 and 30%. So let's see, do we have enough information to answer that next question that I had here? Oh no, we don't have enough. So what next I have to do, I have several problems like these. So work through these. Like I say, watch the videos, work through these problems along with me. And here's another one that you can practice with the NPV profile. Here's the drawing. Here's another one example for. So I give you a lot. And okay, so I give you a lot. Okay, so work on those. And that brings us here. Until this point, what I was discussing with you is determining if you should accept or reject a project on its own merit. And we used the internal rate of return rule and found even that we could solve for acceptance regions of the discount rate when there are more than one sign change. So it's not exactly an investment project. We can't define it exclusively as a finance project. But it has multiple internal rates of return. So that's what we just looked at. What if, rather than judging a project on its own merit, you compare 2 projects? Comparing 2 projects is not as simple as saying, pick the one with the highest IRR for investment projects, pick the one with the lowest IRR for finance projects, or pick, it's complex. It becomes very complex to try and pick between projects that have multiple IRRs as well. So what are we going to do? And I'll show you why there's a problem. Actually, graphically, I can show you here. And this is where we're going to go. So graphically, here's the problem. Let's say you have 2 projects that you have to choose between. Hope you guys have been listening, because I said a lot in a brief time there. There's project A and project B. Now, when you look at those 2, this picture here, it doesn't apply to these numbers. Just this picture here, you have 2 projects. Which one's better? So you could be investing in, you get offered 2 contracts and you plot them, and project A is below project B. How should you conclude? Which project should you take? Go back, whenever you're in doubt, go back to the general rule. Choose projects with positive NPV. Or if you're comparing projects, pick the one with the highest NPV. So which one has the highest NPV? Consistently. Which one is higher? You guys might not be listening right now, but B is obviously higher, right? So B is the higher project, higher NPV. It's the project that you will pick, no matter what your discount rate. It is always a positive NPV. So you should pick project B. Project A is also appears to be always a positive NPV for this range of values, but if you can only afford one, you're going to pick B. So why, what happens? I mean, this doesn't happen in general. It's not that clear. It's not that cut and dry. In fact, it could be that you have 2 projects that overlap. Their NPV profile overlaps. So this project, the bold one, is better up until here. It means if the firm is using a discount rate up to about 8, well, actually, I think we calculate 8%, you should pick project A. But if the discount rate is higher, you should go with project B because it's higher. So in fact, if you compared project A's IRR with project B's IRR, it looks like the internal rate of return, depending if it's a finance project. This is an investment project because the cash flows all go down. You can see here, they're all negative first and all positive. So it looks like, in fact, A and B both have their own IRR. And if you were just to pick the one with the highest return, interpreting it as the return on investment, it looks like you should pick B. But that's not true. You should only pick B if it's if the discount rate is in this range here. So it's not clear. So this happens for 2 possible reasons. One problem is called the problem of scale. The other problem is called a timing problem, and it's all about, well, in the scale problem, it's the size of the project. Okay, so for instance, if you want to choose between these 2 alternatives, which one would you pick? Give me $1 now, and I'll give you $1.50 at the end of class. Or give me $10 now, and you get back $11 at the end of class. Which one would you pick? How would you conduct the analysis? If you use the NPV to conduct the analysis, it looks like you should choose the second option. You get $1 back rather than 50 cents. If you use the internal rate of return, it looks like, if you don't know what you're doing, it looks like, oh, well, 50% return for this investment type project, I should pick the 50% returning project, the first one, not the second. But what's the problem? What am I misunderstanding here? The size of the project. The first project is low budget, so that's why it looks like so much of a return, so high. And the second one is a high budget project. But in fact, in dollar terms, the NPV shows you that you get a whole $1 back, which is better. Who cares that it's only 10%? It's a lot more money than 50 cents. So this is the trick. You have to be clear, you know, these are not comparable projects on that scale. Okay. So think about that. And then there's a problem of timing. This is where you have the crisscrossing profiles. So here's project A that has an investment of 350 upfront, but look as slowly you get a high return of 200 at the end of fourth year. Project B requires a little less investment, but you get the cash flow, you get a high cash flow, the highest actually in the projection upfront. So what this is going to do is cause that crisscrossing of the different profiles. The one, so the first one likes low discount rates, so the 200 stays really high in present value terms. The second project prefers high discount rates, or higher than project A, doesn't care about high discount rates because the biggest cash flow is right away. Okay, so this is why you have that crisscross of the cash flow. So you can check and see here, A is 12.91 and B is 17.8. And if you didn't know better, if you weren't a finance student, you would think you should pick project B, but that's not true. That's not always the correct answer. So how do you fix this? We fix this by calculating what we call the incremental project. Oh, here's some pointers here. The incremental project is calculated by subtracting cash flows from each other. So you want to do that in a way to make sure, I recommend you do it in a way for the initial cash flow to be a negative, so it looks like an investment type project, and that's what I do here. So I subtract them and I have a negative first, negative 100, and then another negative, which is okay, and then the first sign change. So this still can be referred to as an investment project, and you analyze the IRR as you interpret the IRR as a return on the investment. So when we do that, we get a different drawing. You get this bolded, highly bolded profile with one internal rate of return that we interpret as, because we subtracted A by B, we interpret this as choosing A over B. So you choose, choosing A over B has an 8.07% internal rate of return. So you say that as long as this is higher than the discount rate, you go with project A. If the discount rate is higher, you grow with project B, which is pretty much summarizing what we looked at before. And that's that. So we only have a few minutes. So this is what you do for comparing two projects. Subtract the cash flow, so you end up with a negative first, and then interpret the IRR of that project as the and the NPV profile as the project that you're choosing A instead of B. And then I get into the profitability index. Okay, so I think I've taught you guys a lot today. I think that's really it. Watch the videos. See if we can do the last one together before we go, if you'd like, unless you have to be somewhere. I'm going to do the last problem. So here you have 4 projects. You're given information on A, B minus A. They don't show you B, but they tell you about the stream of cash flows. And then C and D, and they say consider only A and B, so these two. By examining the incremental project cash flows, B minus A, so this time we subtract B by A, they are mutually exclusive opportunities, so you can only pick one. If the internal rate of return of B minus A is 12%, so I don't tell you the numbers, but I tell you that if you were to put them in your calculator, you'll get 12%. And the discount rate is 15, what is your decision? So you will treat this B minus A as choosing B instead of A, But this starts as a finance project, right? So what did we learn about finance projects? We interpret the internal rate of return as the borrowing rate, and we want it to be lower than the discount rate. So which of those options say that? Well, I say it in words here. This one's finance. It has to be one of those, right? So which one, A or B? Flip the screen and put on. Oh, no, I can't. It's two different things. Two more minutes, and then I'm just going to leave it to you to work on. No comments? So because it's a finance project, so we visualize this as a finance project because we get a plus and a negative. Going back into what that means for a finance project. Remembering for finance project, we require instead the required rate of return has to be higher than the IRR. So it's either this one or this one. So that since the required rate of return is higher than so this required is bigger than the borrowing rate of picking the project B instead of A, then you should accept B over A. That's what it means. So you guys got to practice your understanding. So with that, I'm going to stop there. I'm going to post this exam on the platform, and I'm going to post your grades today. And I'm going to send an email about what's happening with the test and about March 22 that we're going to meet in the classroom. And I'll probably talk about Unit 4 on March 22. Questions? No questions? Say goodbye. Goodbye. For now, keep in touch. Keep me posted. And let me know how you're doing.